Hello everyone. Today we'll be dealing with a new data set and it's related to mailing to customers of a specific store. And we are given here the IDs of customers. And we also have the amount of spending that they have as a part of the annual expenses they have for the store, or the amount of money that they spend in the store per year. And the age of the customer is a part of the demographic information, whether the person is a male or not, whether the customer is married, whether has or the number of children, the number of children of this person, and whether this person owns the house or not, the salary of the person in thousands of dollars, and if there's a spouse, that's included in here. And whether the customer is close to a store similar to the merchandise, and it could be a no, meaning it's in the middle of nowhere, there's no store similar to that. And whether the customer is a previous customer or not is signaled by 1. If the customer is not a previous customer, then it's 0. Amount of spending of the customer last year is given here, and the number of catalogs sent to a person this year. So we would like to be able to see if the number of mailings have any impact on the customer, and we would like to also observe what type of customer has the maximum number of spendings and has the corresponding type of qualities. For example, it could be a male and unmarried and a person who owns his own house, and that's actually what's going to happen as a result of the data analysis here. That type of customer is the one who spends the most, and then you will like to be able to see the number of mailings we should send to this type of customer. And by choosing such category, or by determining such a category, you can send more mailings of the catalogs to these customers. Now, here one of the things that is different than what we dealt with before is that we categorize the variables as demographic, economic, and relationship to the store of the customer. Now, quadratic models, this is something we covered before. If you go to demographic part, we have feeling that H square could be directly related to the model itself. Therefore, actually going back here, sorry. Let's suppose we have just the ordinary StatPro with all the variables being listed in the way that they are listed here. Age, male, married, children, own home, salary, close to the store, or if there's any similar store close to the customer, previous customer, previous spending, and the number of mailings. So as you can see, adjusted R-square is 72.2%, which is not that high. And as a result of this, we would like to be able to increase the number of variables and incorporate other variables that could impact the adjusted R-square. For that reason, let's suppose we suspect that H square could be one of the variables. Therefore, we add this column and we square H. Variable 47 square here is 2209, and we do that as a column here. And then we also add the salary square here. So if the salary is 64.1, we square that and it ends up being about 4109. And then, as we covered in the previous lecture, we can split mailings into 4 dummy variables in this fashion. So that's something we also do. And also we can actually add mail square as another variable here. So as you can see, mailing 1 square is 1, then 4 square is 16, 3 square is 9, and so on and so forth. And then we use again StatPro for spendings, adjusted R-square 72.1% for the entire data set that you can see here that we have, except including these dummy variables we have mailings 1 through 4, and as a part of this we can actually focus on the p-values, and as you can see previous spending appears as a very low value, but this could be one of the most important factors, so we need to be careful about excluding the variables in this setting. And also as you can see h, it has no impact on that, and h square appears to have a similar impact. Therefore we may want to have a different approach to the model and adjust that r square is not that high. Therefore we deal with something called natural logarithmic variable. So amount spent in total is taken here as the ln. ln is a function in calculus that we get to use, but here we care about the ln of this model because it has a different approach to data analysis. It requires more details to be covered, therefore I'm not really getting into it because it would require you to know calculus 2 knowledge at the university level, therefore I'm not really getting into it. But if you take ln of natural logarithmic, this is a function, ln function, if you take ln of each spending of the customer, or each customer's spendings ln function, then we get to have this column, as you can see, instead of the actual spendings of the customers. Now we are going to remodel this entire data set using natural logarithmic of the spendings. As you can see here, if you stat program, I'm not showing this anymore because you have an extensive knowledge of add-in stat progo add-in usage since we have been covering this all along. You will get to see that the adjusted r-square value can be as high as 84.8%, which is much better. And this is for natural logarithmics of the spendings. And then if you take a look at the p-values, they're reasonably low except some of the ones that we have. Therefore, you can actually have this type of modeling implemented. Now, as a part of the best models, we might be able to improve by excluding or backward elimination. By using backward elimination, we might be able to come up with a better model in this setting. And if you take a look at here, h square, male, married, and here what you will see is that h and h square are taken out, because we get to see that h is not really a big factor here, and it's sense making because it may not be a matter of h for the customer to be a customer of this store. Therefore, as we can see, both h and h square are not really adding value to this model. Now if you take them out, the adjusted r square value is 85.2%, which is not higher from 84.8% significantly. However, we get to reduce the variables here. Another thing that we are actually adding here, which is different than this model right here, is adding multiplication of the variables. For example, you might suspect that male and male multiplication, this means both males that are sent to mail are important, and male and being close could be important. Therefore, we multiply these two, and sending mail to previous customers, both previous customer and mail taken into account. If we multiply these two, then we get to see the corresponding values. For example, as you can see here, the number of mailings 1 times being mail, which is 1, then it gets to become 1. And similar for mail times close and mail times previous. So what you will see here is that mail times previous is another variable, adds value here. But if you actually reduce by using backward elimination, you won't have male times male and male times close. Therefore, there is a difference between this model right here, where we use natural logarithmic of the spannings, and we understand from here that adjusted R-square tells us ln of the output is something we should use, natural logarithmic of the output. But then keeping that and adding 3 more variables, interaction variables, because male and male can be interacting here, which is going to be an important factor, and the other 2 similarly. Therefore, if we get to generate a model by using these variables and using backward elimination, results in this type of outcome, and adjusted R-square is 85.2%, which is significantly high in this setting. Now, continuing from this point on, you can see that we have ln of the salary incorporated in here as the economical aspect of it, which I'm not going to spend too much time on it because it's pushing it further in what we have. You can simply make the model a little better. Here, adjusted R-square is 85.2. Here it is 85.7. It's not really extremely high compared to the previous one under this part. And as you can see here, we have a new column added, ln of the salaries. But I'm not going to get into the details of this too much because this is generating a new variable, and we suspect that ln of the salary might be impactful on the outcome. Now, from all these, you can see that we have natural logarithmic of the output, h variable, then we square the h variable, and we have all the other variables with either 0 or 1 variable value, and the salary and salary square, whether close to a similar store to this store, under consideration, whether the customer is previously a customer or not, and previously spent amount. All these are impactful on the outcome. Therefore, as a result of the analysis here, we would like to be able to predict values, and those predicted values could reflect the reality, or should reflect the reality depending on the conditions. But we need to be careful because these are just reflecting expectations, because these models that I'm talking about here, the corresponding coefficients are in percentage. And here, as a part of the log model, it's same right here, percentage. And the best model we have is also in terms of percentage. And this part right here, we covered different variables, different type of variables. Interacting variables, this is the interaction of 2 variables, just like I mentioned here, male and mailings. And for this one, we have this time being close or not to a similar store and the number of mailings to the customer. So as a part of this analysis, one thing that we should have a feeling of is the impact factor of each one of these. For example, here, as you can see, the number of mailings to the customer, the catalog mailings, and mail being close to another store, whether previously a customer or not. The person who is making the decision suspects that these catalogs have an impact on customers' decision, and especially mails are being impacted by all these catalogs. Therefore, as you can imagine, every time you send out a catalog, it costs something to the store. Therefore, the store might want to minimize this number of mailings to the customers to be able to minimize the cost of such mailings, but at the same time would like to be able to send it to the customers that have the maximum outcome of sending to these customers. Therefore, determining such customers can be through this. And as you can see, age is not really a factor in this setting because it doesn't have much factor on that. And previous spending may not be really a factor either because the customer is already an ordinary customer, therefore coming to the store and shopping in the store all the time. Maybe therefore it may not be really validating in that sense, depending on the decision making. But you may actually want to send this customer the maximum number of mailings because you have the maximum turnout. It's really a matter of decision making and customer understanding at this point. But as you know, this is a data set that is obtained last year. Therefore, it would have impact on next year's decisions. For example, this person right here, let's take this person. The person spent about $5,000 and the number of mailings is 4, and the person's salary is about $87.5 thousand, and the person is a male and owns the house. So if you analyze this data set, this is what you're going to see. Those who are male owning his own house, and married or unmarried, that's something to be determined, but unmarried are the ones that are spending the maximum amount of money most likely. And another thing that's something that you should keep in mind is that this is the combined salary. So if you change this data set to a different setting, then if you split this to man and wife, then it would make a difference in the corresponding outcome depending on how you structure your data. So today I actually explain you a lot of new things, such as the interaction of two variables. When we multiply those two variables, you end up finding new variables that could be incorporated in the StatProGo solution that we covered in the past. And also you learn about natural logarithmic function and how we use it as a part of the data implementation in the outcome. And also this time we used dummy variables, interaction variables, natural logarithmic function, and squared variables, as well as the ordinary variables that we have in the solution, and got a comprehensive variable list and be able to reduce the corresponding variables. And here you can see that all the p-values are less than 0.2, which is our stopping criteria. You could actually further reduce it by taking out owning his own house, however, or his or her house. However, this is one of the most important factors in customers' choice of shopping from this particular store. I hope you all like the fact that through data analysis we can come up with the different models that actually help us the existing data sets from previous year, which can help us to figure out the corresponding outcomes in the future. And you can make decisions through these data analytics techniques, and decision making is an important factor in all these outcomes. For example, here sending maximum number of catalogs to males who are not married and owning their own houses would or could have the maximum turnout in your sales. Therefore, that could be your target audience of sending these catalogs, target customer group. So you can do similar or you can generate similar data sets in your life and come up with all these variables, structure them all accordingly in your workplace or in your life, and be able to analyze the corresponding data through this setting. But you always need to be mindful in the sense that the model that we come up with is a representative of the existing data to a certain extent. And if you like to have a better outcome, you have to, or you need to use, or you can use backward elimination and come up with a good model. However, you need to be careful about the meaning of predicted value. The predicted value should be reflecting what you would like to see as a part of the implementation. So that's being mindful, because when you come up with the corresponding value, you need to criticize the corresponding value, whether it makes sense or not, depending on your expectations. That's why decision making is important. We get to learn these data analytics techniques, but then we also would like to make the best decision corresponding to that. So if our model tells us three of these variables are the most important ones to be considered, then you may want to revisit the corresponding dataset values in this part for all these customers that we have. And as you can see, we have plenty of them. It goes all the way down to 311th row. And also be able to analyze what can happen either in the existing, the current year, or the following year. But in terms of future predictions, you need to be careful, because you don't want to make it too far from current year. Maybe, for example, you have monthly data. You might be able to predict 3 months ahead of time at most. You don't want to go beyond that, because it could be impactful on decisions to be made. I hope you all have a good understanding of the data analytics techniques we covered throughout the camp, and I hope you have a good also understanding of how we make decisions for such data sets through data analytics techniques. Our next lecture will be the final lecture, which is going to just cover the summary of what we covered throughout this summer camp. And I hope you all enjoyed the summer camp and the techniques we covered with the corresponding data sets. Thank you.